So good afternoon. Welcome to lecture 43. Okay. Today it will be the second class. Okay. Already I have taken one. This is lecture 42 already over today. This is lecture 43. We will first finish quickly the last problem of assignment number 4. What is this problem? Quickly let us write down 1 mole of quickly. Sorry. Gold is taken from quickly taken from state 1. What is the state 1? It is given say clearly. E is 1 atmosphere, T is 293 Kelvin. So one thing, small information. Are you in time for the test? That one mechanical in last call today. Yes, in time, no problem. T is 293 Kelvin. 2 state 2. T is 1 atmosphere. T is 273 Kelvin. What pressure must be applied to the gold at 273 Kelvin. At 273 Kelvin, in order to increase its enthalpy back to, back to that of state 1. Call it state 3. Calculate the entropy difference. Between state 1 and state 3. Given rho gold, density, gold 293 Kelvin is 19.30 gram per cc. This is alpha gold is isobaric expansivity. I told you alpha 1 by V. Remember, there will be is 4.32 expansivity, coefficient of expansion. 4.32 times 10 to the minus 5 atomic weight, gold 197. And what else? CP gold. CP gold solid is how much? 23.7 plus 5.19 times 10 to the minus 3 T joule per Kelvin mole. This is the problem. Okay. So this is the problem. Okay, solution. Solution is you try to understand the problem first. Problem says what? See what it does. First one, it is see what it has, state 1 to state 2 is what has happened. See Pressure same, temperature change. You know, the temperature change, so then there will be enthalpy change. DH is CPTT, you know all these things. Under constant pressure, so under constant pressure, temperature change, heating or cooling, whatever. Then there is enthalpy change. Now, next is pressure is changed. Starting from the state 2, at this stage, pressure is changed, keeping the temperature constant this time. Keeping the temperature. So, effect of pressure on enthalpy, for which I gave you the relation, that will apply so that enthalpy is regained. Suppose the loss was something, okay, say 40, temperature cooling, first step, say 30 joule loss. So, what is to be done? By applying pressure, that 30 joule must be regained. So, pressure must be increased by 30 joule. I'm sorry, enthalpy must be increased by 30 joule by applying pressure. If we apply pressure to a solid, okay, solids, okay, this is solid set, solid pressure, then enthalpy will increase. Enthalpy, but effect is okay small. That is to be understood by this problem. Pressure, enthalpy, but not much. Okay, keeping temperature constant. So this is the whole issue. So see how actually the problem is solved. So we first of all start with the systematic quickly. I don't have time to actually. 1 mole, let me write. 1 mole gold. First step, follow. 1 atmosphere, 270, 93. 293 Kelvin goes to what? 1 mole gold. What gold you understand? This is solid gold. Okay, this room temperature gold is solid. So it is not written, but you understand this. 1 atmosphere, what is, yes, 1 atmosphere, 273 Kelvin. What is the name of this state? This is state 1, state 2. What has happened to this one? See, these students, other students sitting here, they have not, go back home, okay. They know that there will be class?
Actually, we have to write a lot of labs.
Oh, for tomorrow?
Tomorrow, day after tomorrow, we have a test.
Okay. But they knew the full knowledge to that. So, this is state 1 to state 2. Find the enthalpy change. So, how will you do enthalpy change? Delta H 1 to 2. Tell me, DH you know, what is DH? CPDT. CPDT 1 mole, N CPDT. N is 1. N CPDT, right? N CPDT, but N is 1. N CPDT integration from what temperature to what temperature? Good boy. Done, okay. Substitute, quickly substitute. So 293, 273, what is CP is given to you? CP is 23.7, write that out, plus 5.19 times 10 to the minus 3 T CP dt. Happy? CP dt. You all said CP dt, okay. That if you try yourself is 23.7 recover. So first you get this first one is 23.7 dt means T2 minus T1. You know what is this? You know integration T2 minus T1. 273 minus 293. Happy? Next one is T dt. T square by 2. T square by 2, and in the limit it will be what? Tell me. 5.19 into 10 to the power times 10 to the minus 3. T square by 2. So by 2, T square is what? T square will be what? T square by 2 with the limits. What it will be? 3 square minus. That's right. Good. That's right. If you apply this, okay, this value is comes as minus 474 minus 29 is all set to be minus. So you are happy that enthalpy has decreased because temperature decreased, enthalpy has decreased. Now what is the second step? You return this. Okay, this enthalpy will be changed, will be compensated for. So next step is what? I tell you what. Now one will start from this. One mole next. 1 mole gold. What is the starting? 1 atmosphere. This is your state 2. Write this state 2. Start from state 2. You what are doing? uptime pressure, and causing an enthalpy increase how much? 500 C. So that it will be returned to the original enthalpy of state 1. That's the. So what is this? What pressure? What pressure? You have to find that what pressure. Calculate P. Call it P in your term. Is it what pressure? What pressure? So call it P atmosphere, sir. P atmosphere. So like P atmosphere, sir. And temperature unchanged. This is isothermal condition. Only pressure change. So what is the state? This will be what is the state? This has been called as what state? State 3. This is state 2. There we go. State 2, state 3. Quickly. What is the DH again? For this delta H, you start with DH. What is the DH? I told you. Effect of pressure V into 1 minus alpha T dP. Is it? V into 1 minus alpha T. This I said. I gave you in fact. Effect of pressure. I gave you when I started thermochemistry. Effect of pressure on enthalpy, effect of temperature on enthalpy. Go back. So this is in the first class test. So V into already I gave you. Moreover, I gave you as this. So what is the delta H? Or delta H is what? Delta H is what? Or write this. Delta H 2 to 3. Delta H 2 to 3. Integration. What is the pressure? 1 atmosphere to P atmosphere. Right. Let P be the required pressure. Let P be the required pressure. Required pressure. Okay. This is to be found. So this is the delta H. What it is? Tell me what is this? It is delta H. We find it out. How do you get this? Molar volume. This is the molar volume. What is given? So this is gram per cc. Molar volume means cc per mole. Molar cc per mole. Make it cc per gram. Invert it actually. So that is 1 by 19.30. It becomes what? I tell you. Cc per gram. Then gram. Cc per gram, Cc per mole, Cc per mole. Gram, 1 mole contains how many gram? 197. So Cc per 1 gram or 197 gram. This is your moles per Cc. Equal, right? Cc unit is Cc per mole. Okay. Cc per, you can do yourself. Quickly. Cc per mole times what? Times what? What is this? V 1 minus alpha is given to you. 4.32 times 10 to the minus 5. Alpha T, V is 1 minus alpha T, V is 1 minus alpha T, okay, dt, what is this? What is your V into 1 minus alpha P? dp, what will get this, okay? Integration, dp. V into 1 minus alpha T dp, pressure is moving from 1 to 1 atmosphere to P atmosphere. What is this? Star this, star this, okay. So I don't want this part, this answer. Oh, sorry. State 1. Sorry, state 2. No, don't. I want this side, star. How much is calculation? Tell me, calculation is what? Give the calculations. Calculation gives what? So tell me quickly, what is this? 10.2, follow, 10.2 with me, 10.2, this is 10.2, this is just 10.2, what you are getting? 10.2 times dp, 10.2 times 2 dp, okay, 10.2 times 1 minus, shall I write once more? So write it on 10 V 1 minus alpha T. Do this 10.2 1 minus. Shall I write this? Write this out. Achha, moreover, this can be taken outside. Independent pressure. So if say 10.2 times 1, do this 10.2 1 minus 4.32 times 10 to the minus 5 dp integration is what? Integration dp is what? Integration dp. T is what? No, see the process. 273. Good boy. 1 to P. So what it is? Let us do this. So this 10.2, let me write. 10.2 times, what is this? This much is what? This much is what? If we do this correctly, this is, acha, I'm writing. 1 minus, this is how much? Can you calculate? Do you have a calculator? Take a look, take a look. Calculator, 1 minus 0.01. About 1000, and 10 to the minus 5, so 10 to the minus 2. So 1 minus, oh, it's okay. 1 minus, it's okay. Don't worry. 1 minus, check, you may check, times 3 minus 1. Happy? Is what, sir? Achha, this is what unit? What unit, tell me? This is cc atmosphere, mole, this is pressure. Alpha T has no unit. Alpha times temperature has no unit. No unit. So this is cc atmosphere, right? cc atmosphere, you want to convert into what? Remember 503 joule. So how will you convert into? Okay. Yes, 100 is liter atmosphere. 1 liter atmosphere is 1 liter atmosphere. Liter atmosphere 101.3 joule. But this cc atmosphere would be by 1000, 0.1013 joule. Okay. So write this into 0.101, for example, joule per liter atmosphere. Just I am removing this line only. This line for clarity. This line. This line. So joule per cc atmosphere. What it will be finally? Do this 1.03 into P minus 1. Take a look. 1.03 times P minus 1. Okay, joule. So this must be equal to what? Tell me. This must be equal to, can I remove this? This must be, that's what loss. This is loss. This must be the loss of joule, loss of enthalpy, loss gain in enthalpy. This must be same as this amount, numerically same, 503, but plus. So these must be equal to what? Tell me. 5 plus 503 joule. So enthalpy is same. Enthalpy. Okay. What is this? Hence 1.03 P minus 1 is 503, or P is how much? P is how much? 491 atmosphere. Answer. Atmosphere answer. This is one answer. For calculate the hot pressure, this answer. What is the state 3? Can you tell me? Can I remove this? Remove this state 3. You clearly see state 3. State 3. Tell me state 3 clearly. So what is the state 3? So state 3 is now clearly complete this. 1 mole gold. Tell me what pressure? P atmosphere. What is this pressure? 491 atmosphere, 273 Kelvin. This is your state 3. What is the question? Last question. Calculate the entropy difference between 1 and 3. Delta S 1 to 3. Start. So delta S 1 to 3. What is state 1 you see? State 3 you see. Start. What is delta S? What is the difference? What is the difference? Tell me. Oh, both have changed. 1 atmosphere, this pressure, this temperature, this. So how look? Yes. Tell me. Acha, I'm doing. Good boy. Delta S, step by step. Delta S, do this. Delta S 1 to 2, I'm helping you. Plus delta S 2 to 3. Pito, 1 to 3. Delta S 1 to 2, you can easily say. What is this? Delta S. Delta is the effect of temperature. Yes. By T. That's right. Good. Very good. Let us do this. NCP dt by T 1 to 2. 1 to 2 means what is the temperature? 1. Tell me. 293 to, this is NCP, right, 273. This is the delta S 1 to 2. First of check. Again, previously we did enthalpy change, now it is entropy change. NCP dt by N is 1. Cp dt by T. And what is the delta S 2 to 3? 2 to 3, tell me, what is the dsdp? Effect of pressure? 2 to 3. 2 and 3 is what? Difference in what? Temperature, same pressure. What is that? For enthalpy, V into 1 minus alpha T dP. For entropy, no, I have given you last day in the class. Forgot. V into ds dP minus alpha V. Recall. Note here, note. Del H by del P, effect of pressure. Never forget V into 1 minus. This problem is, this requires this knowledge. And delta S by delta P, quick. General. You apply this for ideal gas, how much it will be? For ideal gas, this for any. Alpha is what? 1 by T is 0. Ideal gas, enthalpy does not change in isothermal condition, isothermal process. So you know DSDP is what? What I said, minus, I gave you these instructions already so that you can solve yourself. So 2 to 3 is what? Minus, tell me, plus means minus alpha V, tell me DSDP. So ds is alpha V dP. dP is what? Integration. What is the pressure? 2 to 3. 2 to 3 pressure is what? 1 to 503. 491. 490. Sorry, I'm very sorry. 491. That's right. It's okay. So do this, complete this. How much it is? Cp dt by T. So please, I'm quickly writing. Cp dt by T. Okay. So this is how much I'm giving you. You try yourself. 20 is too much, too lengthy actually. 1 by 1 it is better. So let us do one thing. Actually, let us do one thing. I'll do this later. Delta S 1 to 2. First 1 by 1. Complete this. Delta S 1 to 2. Is what? Do this. Complete this. Cp dt by T. What is this? Cp dt by T. Okay, again substitute. Cp is given there. 23.7 is 23.7 plus 5.19 times 10 to the minus 3. This is better. Cp dt by T. Cp in bracket dt by T. Happy? And then 293 to 273. How much it is? Complete this. First term is dt by T means ln. dt by T means ln. So 23.7, write that. 23.7 ln. 273 by 23.7 ln 273 by 293. And what is the second term? T dt by 2, tt cancel. So 5.19 times 10 to the minus 3 cancel dt remains. dt integration dt is t and between limits 273 minus 293. If you do this yourself, then you will get these values. Quickly do this. Is what? Minus 1.67. You try yourself. Minus 1.67, and next one is minus 0.1. Minus 0.1. What is this result? Minus 1.77. What is the entropy unit? Joule per Kelvin. This is 1 mole. Per mole means 1 mole. This is delta S 1 to 2, and delta S. Can I remove this part? And star. Delta S 2 to 3. Double star. Say double star. Delta S 2 to 3. Then it's all over. Delta S 2 to 3. Tell me. This is already I wrote. Is it effect of pressure? 2 to 3. Effect of pressure like enthalpy. Effect of pressure. Relation. That relation. So it is what? Minus alpha V. ds is what? ds is what? ds is minus alpha V dP. Minus alpha V dP. So minus alpha V dP ds and integrate it. From hot pressure to hot pressure, 1 atmosphere to, tell me, hot pressure? What pressure it is? 491. This you have to do, okay? And do this. So this, what is the alpha V? Put the values in. Minus, what is the alpha? 4.32 alpha is what? Right, that. Times 10 to the minus 5. Okay? It's okay. Can I remove this? Can I remove this? This is all over. Since all over. These are all over. So remove, clean this part. Minus alpha V. What is the V already? What is the V I wrote here? What is the V? 10 point, very good. Times 10.2 cc per mole. Good boy. Helps me. 10.2 is okay. 10.2 times what? What this you tell me what? What is this? This is outside. Minus alpha B outside. 490. 490. 490 subtract integration, okay? 491 minus 1. 491 minus 4 is 490. Times what? This is Cc atmosphere. Again Cc, see follow. Cc atmosphere, alpha has no unit. Alpha, what has happened? Alpha has a unit, Kelvin inverse. How is it, okay? See, right. dsdp, I made a mistake. dsdp is alpha v. ds is alpha v dp, alpha v dp, okay? So, what is,
We know that the enthalpy change from state 2 to 3 is 503 joule, and we know the temperature. So we can directly.
No. You know, temperature is a function of temperature, perhaps. Maybe you could check this.
Temperature is constant.
Possible, you can maybe. Let us check after this. Let us check this. Quickly. You all check. So alpha is 1 by t. So what is the unit? This unit is, okay, should be each time, okay, it remains there. It remains. Per Kelvin remains because this is entropy unit. Per Kelvin remains intact. So this is what follow. This is a per Kelvin, and this is what Cc. 10.2 cc per mole, and 1 mole is actually involved. Mole, and this is what? Atmosphere. Cc atmosphere is times point. What is the value? I told you 101.3 here. 0.101 conversion factor. Conversion factor is what? So what is the unit? Joule, right? Joule per Kelvin. Joule per Kelvin. So what is this value? Do it yourself. Minus 2 terms are there. 490. 2 terms are there. Okay, what is the value? Minus 0.22 joule per Kelvin. So this you have got. So underline. This you underline 1 you have got. This is the second you have got. What is delta S? What is the requirement? 1, 2, 3. Complete now. Now remove this, all remove. Hence, again here from here. Repeat this. Hence delta S 1 to 3. What is the here? Delta S 1 to 2 plus delta S 2 to 3. Happy? Delta S 1 to 2, delta S 2 to 3. What is the delta S 1 to 2? Minus 1.77. What is the delta S 2 to 3 a moment ago? Minus, both are minus. Minus 0.022 is what? 1.79. 0.022 is okay. Minus 1.79 joule per Kelvin. This is the answer. 79. Okay, 7702. Omit this. Give two, no problem. Actually, check that one. What you said.
No, sir.
That is not.
Pressure is not constant.
Good point. Very good. So okay, over with this assignment. This call 4 is all over. Okay, answer. First part, second part. What is the first part? Pressure is what? 490. What is the pressure? I said. What is the pressure? Tell me. What is the pressure we applied? 491. First part. Second part. What is the entropy change? For the 1 to 3. Clearly know what is the state. Okay, good point. With this, thank you very much. Let us move on to the next one. Any questions you can ask me?
That will be 0.02. Minus 0.02.
Minus 0.02 joule per Kelvin.
0
to sure.
You have done that.
Oh, I'll check this. Thank you. Let me check. Maybe in hurry actually, I was not. 0.002. No, 0.02. Oh, 0.022. Thank you. Thank you so much. So minus 0.002. Is okay though? Good, very good point. Minus 0.02 joule per Kelvin. So right, note this. This is a gas scale problem. So answer I wrote. Answer. Note. This is a gas scale problem. I forgot to mention. This is a gas scale problem. This is a gas scale problem. taken from Gaskell's book, okay? So you can take a look. So with this we have over. So next is remove. How much time will get more? Half an hour? 15 minutes, 15 minutes, okay. Let us see how much we can do. So remove this, assignment 4 over. So so with this assignment 4 is complete. With this assignment 4 is complete, is solved, it's completed. Next is what? Next is what? Gibbs free energy. Gibbs free energy and Helmhotz free energy. Free energy. Okay. Okay. So with the introduction of like note, important note, with the introduction of Gibbs free energy, Gibbs free energy, G, symbol G, we formally begin chemical thermodynamics, a study of chemical thermodynamics. This is all thermodynamics, classical, but it is chemical, purely chemical reaction. So Gibbs free energy is required. Chemical thermodynamics. We may know this. So to solve any chemical reaction, Gibbs free energy will be required. You'll mostly consider Gibbs free energy. It is crucial to solving problem. So entropy will be needed, but based on Gibbs free energy, we will proceed. So start. You see, second law criterion. What is the second law? Follow this. I am actually still continuing the second law. You follow. You don't want to know all these things. You follow the second law. Second law is what? Second law, ds. Tell me, universe greater than. See, I return to the ds system plus ds surrounding greater than equals to 0. This you know, but we are interested to, but we are interested to find a criterion, to find a state function, find a property, find a criterion of spontaneity and equilibrium in terms of system property, not universe. Equilibrium in terms of system only, in terms of the property of system only, property of system alone, not in terms of universe, not in terms of universe. Follow this. This is the development today. Very interesting development. Not universal, so not entropy. It should be such system alone. We are trying to do this. So start. So let us. So for this, okay. Let us consider. So how I going to from universe to C? Okay. So ds universe. So let us rewrite. Also, We see, let us, DS universe, you start this. What is this? You tell me what is this? Tell me what is this? Refers to spontaneity or what else? Tell me. Condition, irreversibility. Recall. How will you forget this? And equal sign refers to what? Equilibrium or reversibility. You don't know this. And what I have not written here? Less than. And less than. And less than. Impossibility. These are second law I am repeating. Okay, we have so many times we have discussed, and we have highlighted this, and we have stressed upon this possible, impossible, and equilibrium. Or spontaneous, impossible, equilibrium. So this is the criterion. So let us start with. We start with this, and let us see how we get a criterion in terms of system alone. Follow this quickly. Or write DS system plus DS surrounding greater than equal to 0. Happy? Or DS system. What is DS surrounding? Please tell me. Minus dq process. Minus dq process by T surrounding greater than equal to 0. What is this? Write this. Or DS system plus I am writing this here. This I am writing here. This I will save actually. Or DS system. Write this. Plus dq process is what? dq process is what? So minus, give the minus here. What is dq process? Tell me. Minus is absorbed here. dq process is du plus dw process. Du process also. Du process you can write. Du process plus T surrounding greater than equal to 0. This I often consider this. Du process you write. Du process you write. Okay, from this. Now I remove this. Start from this point. This point we will always start. Okay, remove this. And this criterion you remember this. Okay, these are again rewrite. Greater than, spontaneity, irreversible, equal sign, equilibrium, reversible, and less than, impossible. Okay, so start from this point. DS system writing or DS system. Remove this, all this, make some room for writing. Okay, writing some room. Start. Or remove this also. This is already written once more. So just this we will retain, and I will work with this quickly. DS system or DS system. DS system is DS. DS system we don't write like DS. Du process, right? Du process. Du is du. Okay, for process reversible. Remember, both we are addressing. Note, both we are addressing. Reversible, irreversible. So careful. So but you write. No. I'm sorry. Consider. Here important. Consider a constant temperature and constant pressure process. Both. Temperature, constant pressure process. But both are constant. Consider a process under constant temperature and constant pressure. So what you write? So we get or TS system is DS. Du is how much? Du is du. What is this? dW process, what shall I write? Can you tell me? See, constant temperature, constant. Can I write PdV? Sure. What is the reason that I can write PdV? What is the reason that I can write? dW is PD, constant pressure, not reversible. Because why not reversible? Irreversible also is there. This side is both covering both, so not for reversible, but the argument is constant pressure. So PdV. Follow this. Follow this. du is du. Process actually state function by T surrounding. Write T surrounding. No. Is greater than equal to 0 quickly, or ds minus what is this? du plus pv. Oh, one thing I made a mistake. dq, what is this? ds, dq process children, du plus dw process. Oh, I am very sorry. You change this. dw process, it is what? dw is how many types? Mechanical, non-mechanical. Unnecessary du process is what? You don't have to write du process, you don't du mechanical plus dw prime. Okay, remember dw contains mechanical, non-mechanical. This is non-mechanical. This is non-mechanical. Sorry, non-mechanical work. This is mechanical work. Okay. dw prime. So I am very sorry. That's why this trouble is coming. Follow. du unnecessary process you don't have to write. So dq process is du plus dw total. So dw in two parts, mechanical, non-mechanical. So du plus, so pdv what shall I write here? Plus what? Tell me. dw will unchanged. So this du plus pdv, are you sure? Achha, T surrounding what shall I write? Isothermal condition. Constant temperature what shall I? Is there any difference between T surrounding and T system in the constant temperature? So T system. T surrounding is right. T system, then you write T system nothing but T. Okay, greater than equal to 0. Any problem? Have you followed? Why it is PB? PdB is what? PdB is what? Under constant pressure. dPV. So du plus dPV is du plus PV. Okay, or what? Or what? Or you are getting what? Tell me. Or TdS, let me write TdS minus du plus PV is known as H plus, okay, right here. Minus dH minus, break this, minus dw prime greater than equal to 0, or TdS minus dH greater than equal to dw prime. Take a side change. Repeat. H dH plus dw minus is there, both minus greater than equal to 0. Retain minus dH left hand side, right hand side goes to dw prime. What is this? Or what is this? Tell me dTs. Why it is dTs? Why? TdS is dTs. Constant temperature. So that you should very smartly use this. Greater than equals to dw prime. Or I am writing further. Ts minus H greater than equal to dw prime, or dH minus Ts less than equal to minus dw prime. You know, side when it is take the negative both sides, greater than become less than. You know, take negative both sides, greater than and if there it become less than. Okay. Now since it is very important, now see the how Gibbs finite begins. How is invented. How? H minus Ts, okay, if it is 0 non-mechanical work, then dH minus Ts is 0 at equilibrium. So serious issue. So this will be 0. So that means this function must be an important function. Like U plus PV is an important function. You call it H. Today H minus Ts similarly an important function. Let us give a name to this. We will not carry H minus Ts all the time, which is so important. Your new name. What is the new name? G. Gibbs finite. Let us call H minus Ts name. Let us call is G. This is Gibbs free energy. Gibbs free energy. Happy? And I note here at the same time G is a, tell me, H is a state function. H is a state function. State functions. So what is G is also a, so G is also a state function. The new state function is obtained today. New state function. What is the name? Gibbs free energy. G. or what you write, or dg less than equals to minus dw prime. That is let me write, that is what I am writing here. I am writing here, that is dg prime, dg, okay, this is actually dg, okay, dg prime, dg pt, is under constant pressure temperature consider. So dg pt is less than minus dw prime, and give a box. This is the outcome. This is the outcome. Okay, and you can see less than refers to what is the now right. Now right. What is the less than means? Less than is what? Tell me. Less than is becomes now. So this is okay. This is okay. Acha, right. Less than dw prime. Acha. Remove this. Remove this. Acha. Or I'm very sorry. You right here. Acha, right here. That is dgpt less than equals to minus dw prime. Sorry, unnecessary, I wasted time. Okay, I mean dgpt is less than minus dw prime. Okay, so start this, double star. When dw, in the case dw prime is 0, is impossible. Example of dw prime is what? Electrochemical work, surface work may be absent. In the case dw prime is 0, no non-mechanical work. Okay, in the system, no, is 0. Then what is the condition? Then dg pt less than equal to 0. dg pt less than equals to 0. What is the equal sign? This is refers to what? This is refers to, tell me, spontaneity. When a chemical reaction will occur, this is the condition, less than 0. Or irreversibility, similar thing, or irreversibility. And equal sign for, tell me, equilibrium, or when equilibrium, one reversibility. And right greater than is impossibility. Happy? This okay? So this is okay already. So you got this. So box this. This is your. Okay. So this over quickly over. This is okay. So I'm removing this also from this place. Unnecessary. Keep it only one. Okay. So this you retain quickly. Next. Again consider. Again consider. Again consider this equation. This I am writing. First two I am writing. I'm not writing first few steps, keeping here. First 3 steps here. So I am repeating this. Now again consider. Is again reconsider. Yes? Now reconsider. Reconsider what? Write this. ds system minus du. I will define condition I apply. Similarly, constant pressure, constant temperature, remove. Constant volume, constant temperature. What is this? du plus dw mechanical plus dw prime non-mechanical, T surrounding greater than equal to 0. See, here it was greater than, becomes less than. Have you noted this? Greater than become less than, equal remains equal. Okay, because entropy is greater than, free energy is less than. Okay, or now under what you consider now? Under constant volume and constant temperature. Okay, under constant volume and constant temperature. This is a process under constant volume, constant. Tell me what will happen? ds system, ds minus. Let me write with me. du, very easy. dw mechanical is what? Zero mechanical PdV, constant volume is 0. You don't have to. Plus 0 plus dw prime by T surrounding. T surrounding will be what? T surrounding will be what? Temperature are same as system. Isothermal, both are same. T system. Okay. This is T. What is? Will be 0. Constant temperature. Tell me. You tell me. Constant temperature, du is 0, who? When we consider? When we consider? Ideal gas, change, isothermal change for an ideal. Where is the ideal gas here? For a chemical gas, zinc plus copper sulfate, metal plus oxygen, where is the ideal gas? For the process. But change is in the process, initial to final state. Du is, that is for purely ideal gas, not even solid, not gold, no. It is just any reaction thing, all reactions on earth. Okay? Or what will get? Tell me. Or can I write here? Or TDS, right yourself, minus du minus dw prime. Sorry. Yeah, right here. Greater than equal to 0. Greater than equal to 0. Or do this. Or dTs minus u. You know very well. dTs. Again, temperature constant. dTs or minus u. dTs minus u. Yeah, minus dw prime greater than dw, or write dTs minus u greater than equal to dw prime, and change it, and last line change it, or du minus ts. U minus ts is less than equal to minus dw prime. So what is the difference? It was dgpt is less than minus dw prime. I wrote this actually. Right, dgpt. Right, that minus dw prime contrast. It is now it is something else. U minus ts is less than again it will, if it is 0, then it is again a serious function, important function, crucial function. U minus ts is less than equal to 0 for reversibility and irreversibility, for equilibrium and spontaneity, must be important. So let us name, give a new name, don't carry. So let us call, okay, right. Shall I remove this? I am removing this line, keep it here. Let us call the star, let us call u minus ts as what? A. State function, why? These all are state function. All are state function. A state function. So, okay. So what is this you are getting there? A. Can I remove this part? Or what are you getting here? dA less than equals to minus dw prime. Contrast dgpt less than minus dA. That is what? That is, tell me, dA constant. This is under constant temperature volume, not constant. So Tb less than equals to minus dw prime. So write this dA Tv or Vt, whatever, right, minus dw prime. Box these two. These are the two important observations you got. And when dw, right, remove this, all remove. And when dw prime is 0, and when special case, okay, it is generally true. This is generally true. When dw prime is 0, then dATB is, tell me, less than, is 0 means less than 0. Okay, d is less than 0. Okay, that is, see here, dgpt, dATB, okay, or Vt you can write, or you say, okay, this. Again, same thing, these are the conditions. So write here. So write it back, top here. So let's complete this, right here. One you have got, second you got. dA, Tv or Vt does not matter. We write this, less than equals to 0. Again, this less means spontaneous, equals means equilibrium, greater means which I have not covered, impossible. So less means spontaneity, reversibility, equilibrium. So this is another one. 2. Similarly, you can prove, similarly it can be shown, what you can see, just quickly, you can show this. dH, you try yourself this one. This is actually assignment problem. 5. dH SP, entropy and pressure constant, less than equal to 0 or minus dw prime. You do this, then dw prime set 0, then you get this. This is, and in terms of enthalpy criterion, in terms of this free energy spontaneous criterion, equilibrium criterion, in terms of Helmholtz free energy criterion, in terms of enthalpy criterion, in terms of internal energy, what is the criterion? SV less than equals to minus dW prime. Okay, these are the 4 equations that you set up, okay, like this here. Okay, so try yourself, do yourself. One of them is in the assignment problem. I'll discuss next class. Okay, this is your, this you have to do. Okay, try yourself, starting from where? Similarly means you start from this. I tell you, start from again. I'm helping you. So constant entropy. I'm helping you. Constant entropy, constant pressure. What will do? Constant entropy means this will ds is 0. See, like this you try. So use this, and constant pressure means you know what is constant pressure. dW mechanical is PdV. So you try yourself. Over. So quickly, this is over. Quickly. Can I remove this? All over. Never ever forget this. Whole life. This will actually build up your chemical thermodynamics. It is only this. So remaining part of your study. This is so important, so crucial. Can I remove this? Quickly. Just time 1 minute it will take. For a fixed mass, how much time I have covered? 1 hour over. 1 hour over. For a fixed mass and fixed composition, it will not take much time. Fixed composition system. Next class. For fixed mass, fixed composition, like example, quick example, EJ. Tell me, EJ. 1 mole ideal gas, always. 1 mole ideal gas, 3 mole iron, 4 mole water, etc. Fixed mass. So, example. I start. G is H minus T. Follow me. G is H minus T. Free. So, no, don't use this constant, DGPT, etc. Okay. Don't use this. Oh, I have removed this and now. Just now I removed. I didn't get space. DGPT less than equals to 0. DATV less than equals to 0. DHST less than equals to 0. DUSV when dW prime, when dW prime non-mechanical is absent. This I've got already shown. Okay, this G is H minus, but G is H minus T. No constant there. TP don't apply. G is G. G is H minus a state function. What is DG? What is DG? Try tell me. DH minus TTS. With me. DH is what? DU plus H is U plus PV plus 3. H is U plus PV. DU plus PT plus I'll stop. Okay. Minus TDS. Oh, what you didn't ask me? DH minus TDS. Okay, is okay. Minus. How can it be okay? Is under constant? No constant. Pure. Freely. So DH is what? H is U plus PV? Not here. H is U plus PV. Apply that. You apply here. Then U plus PDP plus PDP. Minus TDS minus SDT. Now in a reversible process, consider reversible process. One mole ideal gas you have done. Okay. What is this? Du is what? Continue. PdV is known as dW reversible process. PW is dW reversible. So can I write this? dW reversible. Which dW is dW? For reversible I have already mentioned. So dW plus VdP. TDS is what? Anyone? VdP is dW reversible. PdV is dW reversible. What is TDS? Reversible process dq. ds is what? Okay, noting for reversible process. I am writing is dq minus sdt. Note. What is the definition of ds? ds is what? dq reversible by t. So what is tds? What is tds? dq reversible. And reversible I have already mentioned. Actually, these are reversible. So du plus dw is known as a what? What this is known as? These together is what? dq. Achha, write this. This is dq. Sorry, you will not mistake. Write one line. So dq, first law, plus this dq minus dq, this close vdp minus sdt. So what you get? Plus dq minus dq cancel is what? vdp minus sdt. So So write this out here, right here, here. dg is VdP minus, for what system? For what system? For fixed mass fixed composition system, right? Right here. This you remove, gives free energy is over top for fixed mass and fixed composition system. Fixed composition system. Right here, I'll just give you quickly. It's over. This is what important relation. Box. I'll give you another. It's okay. Acha. This is right question. Applicable for reversible or irreversible? Reversible, I said, but you can apply for irreversible also. Why? This relation you can apply for irreversible. A process working between 1 and 2, reversible is this. Irreversible will be what? State property. dg is a function, g is a state property. So you will be applying for, since g is a state property, applies to both irreversible also, because same result. So he apply for reversible as well as irreversible. So applies to both reversible and irreversible, since g is a state property, since g is a state function. I'll show you. Suppose you argue. Suppose I show you. Irreversible. I'm doing this. Consider irreversible. Here, say. See, if it is irreversible process, if you have argument, just once, I'm clarifying this argument. Suppose you're arguing, sorry, it is VdP minus SDT, but you start, I'm writing du. What do you write? For irreversible, dW reversible is PdP. Suppose isothermal. Keep in your mind isothermal. I'm telling you. Constant pressure, constant volume you can consider isothermal. Easy. Okay. Constant pressure is easier. PdP is what? dW reversible is what? PdP. dW irreversible? Isothermal. Less than dW reversible. It cannot be PdP. Isothermal. Constant pressure? Same. No problem. In the constant pressure is very easy. Well, this will not change at all. Okay, so it is PdP will be greater than dW is less. Oh, sorry, PdP is greater. Happy? Mechanical. PdP is mechanical here. Okay. Irreversible process. dW irreversible. This means dW irreversible is less than PdP. You agree? Continue. Plus VdP. Quickly. TdS you wrote what? TdS is dq reversible by T. But you know, dq reversible is isothermal process. Consider isothermal process. For your consider isothermal process. Okay. And isothermal. This actually for helping you. Isothermal. So tell me, ds is dq reversible by T. Now about reversible dq and irreversible dq, which is same. Isothermal. dq is du plus dw. dw is different, so is dq. So du is same. dq. So this is again. So dq is actually it is greater than. Tell me. Sorry. It is ds is dq is less. Okay. dq reversible is greater than dq irreversible by T. Happy? I'll repeat. Follow. dq which is greater? dq reversible is greater or dq irreversible is greater? To answer, because same as dw reversible and dw irreversible, which is greater? dw reversible greater. So here dq reversible greater because du is same, both are the same. So this is greater. That means what? That is, or TdS is greater than dq irreversible. Happy to? So what you will get here? TdS what you will write? Greater than dq irreversible minus SDT. Now we will check this. du plus greater than dw minus dq. First law is actually, this is nothing but this is what? Greater than dq irreversible, and this is minus greater than dq irreversible. So it is right here. So greater than dq irreversible, and take this here minus greater than dq irreversible plus VTP minus SDT. What is this? That exactly by same amount. So So all set. So have I made any mistake? That it will be same for reversible and irreversible for simple reason G is a state function. I'll stop here. I stop here actually. Then there are other three. I will do the next year. You have to look tired. DG and similarly next class the enthalpy DH and DU. Next class, quickly, this I will show and other things. First I will complete this. Then I have to see this is taking time. Then I have to assignment problem. Assignment problem actually what you will do. Okay, let us. So with these words actually we have concluded the class. We have concluded the class. Okay, so we will see next class. So if you have any questions, you can ask me.